joined the meeting.
Hello, everyone. Can you hear me?
Yes.
Okay. Good evening, everyone. So today we are going to learn multiple regression. And in Minitab, how do we do? Where is the option? So you can see the screenshots right here. Can you see my screen? So so right here, we are just going to use one option under regression, which is fit regression model. So regression, fit regression model. So we are going to use only this option. There are many other regression methods we are not going to use, like logistics regression, nominal logistics regression, binary logistics regression, different kind of, different methods are there of regression. But our purpose is to learn very simple, and that is regression, fit regression model. So what is the process to learn and what are the steps in learning the regression model? You can see these slides at the bottom of the module with a screenshot. There's another way to do the regression. You can go alternative way. So you can see in Minitab assistant. Under assistant, you can see multiple regression, simple regression. These are the options you can choose. So if you have one variable, dependent, one independent, simple, many independent variables, this is multiple. So you can use this also. So before going into multiple regression, we have to check the correlation. So as you know, what is the regression? Let me briefly explain on the whiteboard, then you can understand, then we will go into the so let's say two variables are, so our spending depends on our income. Let's say this is income and this is spending. We all depend on the income. If we have good income, we spend more. If we don't have that much, so let's say this is a graph. If you have more income, you spend more. So spending is a function of income. Now look into that. This area, this is called intercept. This distance, it is called intercept. Now point any two places, just put the point, just make 2 points on the line and draw perpendicular and horizontal lines. So vertical and horizontal lines. So this distance is on y-axis, this is on x-axis. Del y, distance by, this is, you can say, del x, distance of x. So the slope can be, it is also known as gradient or slope, equal to del by or distance on y upon distance on x. This is slope. So what is the equation of this line? I mean, we know from our childhood that a straight line equation is equal to y equal to a spending equal to, I would say simply, spending equal to spend constant plus another, this is constant, this is called intercept, or you can say I would say intercept plus slope into income. So this is a very simple regression. Spending depend on constant, which is intercept, this intercept, plus slope, which you can. So now I put income value and I can get the spending value if I know these two constants. So in regression, we are multiple regression. We have multiple, one intercept, multiple slopes because multiple variables and multiple variables and multiple slopes. And based on that, we predict the dependent variable. So this is just 2-dimension, but multiple regression is based on multiple variables and multiple slopes. So this is the simple concept. If you understand, let me go further. So before going into that, we would like to see how the relationship between spending or income is there. So I'm just going on my mini tab. This is a mini tab. So I just, these are the variables and all the data like 200, 500, whatever, 500 numbers, 502 are here. So I'm going first, please mute your microphone. First step is to check whether there is a relationship between these variables or not. So I just go under statistics, basic statistics. There is a correlation option. So here I just select the variables. Now under results, here I can say pairwise correlation table. Okay, that's perfect. Here you have different options. Store correlation. Here we have Pearson and Spearman 2 method. By default you choose the Pearson because that is widely used. Results, and then you can also see the a matrix plot, but we are just going to check this option pairwise so that you can get the p-value. You can see this is the matrix which is right there, number of row used. This is the correlation matrix. You can see it is not, so it is going, two variables are going, they should come right here, but since it is big, so you can see the correlation matrix right here. Now from naked eyes you can see which are the highly correlated values, which are the lowest correlated values. But you can see the significance from here. So all pairwise comparison is here. This is the scanners versus over value. This is correlation 0.057. P-value is 20%. That means, is it useful or not? So basically, similarly, you can see the same concept that we have applied in the past course. Correlation, you can see which is 0, which is higher than 5%, lower than 5%, means same concept. P-value is less or more. Based on that, we can choose whether that is useful or useless. So for that purpose, I'm just going to share again the so correlation null hypothesis, rho equal to 0. Rho means the correlation of entire population. Alternative rho is not 0. And when do we accept, when do we reject null and alternative? This is reject null hypothesis if p-value is more than p-value less than alpha value. So if you look into this, which just Just where's my monitor? Oh. So which are going to be useful here in this? This is more than means entire. So this is useless. This is useless because by default this is useful. This is useless. This is useful. 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 This is also useful. This is useless. Useful. You can see by, one by one, which are useful or significant, which are not significant. Now, once after, you do this, the second step is to start the correlation, regression. So I'm just going again on my mini tab. So here I just statistics, regression. Again, please don't use any other option. Just use the regression and fit regression model, because this is based on ordinary least square method, OLS. Now here this window will pop up. Under this window, you can see the response variable, which is dependent variable. So continuous variable. So I'm just going to select, let's say all of them here. Categorical variable you can also select if you have like, male, female, if you have, yes, no kind of a variable that you can select here. But so that you will get separate model for categorical variables, but you can also put here. Now, these are the other options that you have to check. So here, you have the storage. You can store residual because we are going to check the residual. So I'm just going to store residual. A standardized residual, I already spoke about, I already, explained in past class. And so this is another thing, is standardized value of residual. How to do z equal to x bar minus mu upon sigma. So these are the options. So I'm just going to store residual. What is residual? I'm going to explain also. And there is a Darwin-Watson test. That is, if you have time series data in regression, you can also use that. Graphs, you can see different graphs. I don't want, I'm not going to. And then other options you can check, leave it by default. And I'm just going to. Now you can see the regression is right here. This is the equation. So as I explained to you, this is intercept, which is true. This is a slope of a scanners. This is a slope of a scanner. This is a slope of lift. This is the lift weight of, slope. This is trail view. Means these are all, this is our regression model. We got this regression model. Based on this regression model, we can predict the value, which is, I can go here, statistics, regression, and I can predict once I make. If I put, these values of scanner, lift ops, and all, and I can get to know what is the overall value. So this model has been made. Now our question is that whether this model is valid or not. So we are going to check the validity of this model. A very simple thing is to go one by one on this. So basically, first step is to check whether our intercept is significant or not. That, you can see the constant. The null hypothesis is all, or you can say constant. All constants are 0. null hypothesis. So let me show you in my this slide. You can also do the this plot. So simple regression. So null hypothesis says, all right, let me write on whiteboard. Let me write on the screen. So null hypothesis says intercept all slopes and intercepts equal to 0. So this is null hypothesis. Alternative says all slopes and intercept not 0. What is the meaning of this? If we prove null hypothesis, let's say this is a 0. Null hypothesis we proved. That means if suppose this is a, let's say which one is, so a scanner, the value is 84%, which is higher than 5%. We accept null hypothesis in that. So scanners, where is scanners? This is the one. Means this
isn't the alternate hypothesis just any of the slopes is not equal to 0?
Yeah, is not equal to 0. Not equal to 0 mean it is have meaningful. So you can say this is useless if you have more than, in simple word, useless in model. And this you can say useful. So basically scanners, if this is a 0 means it will be 0, means in overall prediction, this variable scanners is having useless. It is not useful. So in entire equation, because it's the p-value is more than 5% in entire model. So now we are going to check in the model which variables are useful for predicting the overall value and which variables are not useful and not useful. So I'm just going to mark here how many variables are useful and useless. So you got the answer of your question? So this is, yeah, go ahead.
I was just wondering, like, for null hypothesis, all of the slopes are equal to 0. So that means if a single one of them is not equal to 0, then you accept the alternate, right?
Yeah. So basically, yeah, because instead of writing, one by one all, so I'm just simply, making here. So I have to write intercept, one by one, I have to write 10 times. How many variables? 1, 2, 3. Look into like 10. I have to write 10. Okay, these are 13. So 12 hypothesis, alternative, 12 times, alternative, and 12 times null hypothesis. Instead of that, I wrote this. So you can write, usually in book, I can show you in book. So where's a book slide? So do they have? Certainly they would have. Okay, here you can see, or you can see this null hypothesis and alternate, all true coefficient are 0. Can you see this? And alternative, instead of writing one by one, or in other words, you can see, v1, v2, or whatever, intercept and whatever slope are 0. And at least one of the coefficient is not 0. Alternative is this. So instead of.
Now, for the p-values, is it useless when the p-value is high, or is it useless when the p-value is low?
I think that is a basic rule that, what p-value we learned in the last course 503. When we accept the null hypothesis, do you recall the last course? Do you remember?
It was, wouldn't it be if it was less than 0.05? Then we would reject the null.
Yes, that's correct.
So my question is, what if only one of our variables was under, on my regression model, I only had one that was less than 0.05.
Yeah, then perfect. That is the only significant predictor in that model.
Okay, and did you want, because I had actually done like 3 regressions where I was getting rid of the useless, quote unquote, useless variables. Did you just want us to do one with all the variables, or did you want one regression with just the useful variable?
So you have to do with all the variables. First question or first fill in the blanks is related to, I am just going to show you, so that you have to do with all, and then you are going to make the point which is going to be useful, which is not going to be useful. So let's say this is the one, and I think first question is few selected. This is dependent variable, and 1, 2, 3, 4, maybe 3 or 4 are independent. So it is clearly given which are going to be dependent, which are going to be independent. Not all, like I have selected all as an independent in question 1. I think first you have to select only this, or 4 independent, and this one dependent, and then
Okay.
So please read the question. All the information is right there. So
my question was referring to the discussion.
Oh, discussion.
Yeah, sorry.
Okay, discussion is about, you have to select the home value or home price is a dependent variable, and rest, like a lot, constructed area, this, all bedroom, bathroom, garage.
Yes.
All independent. So, one is home price equal to intercept plus slope, and I already wrote a, like a equation there. So you are going to have this model, like, 1 and rest independent. So home price equal to this.
Yes. So I went ahead and did that, but my question was, when we do the regression model for the homework, did you just want us to show the regression model with all the variables?
Yes.
And then for us to just explain
Yes.
which are the useless and which are the useful variables?
Exactly. You
okay.
have, so you can, explain, because that is the complete, that you can say bedroom is not valuable. Bedroom
Okay.
or bathroom is not valuable, or garage is not valuable, or, so you are going to talk about one by one. Okay, this is not, because the p-value is more or less. So we are directly going here, based on p-value, which are useful and which are not useful. And I can demonstrate, right, in just 2-3 minutes, you can see.
Okay, and then I just have one more question. I'm noticing that on some of my variables, the coefficient seemed to indicate that it was useful, but then when I was looking at the p-value, it was showing that it was over 0.05. And so would then we just base it more on the p-value versus the coefficient?
So coefficient is just, slope,
Yeah.
slope or intercept. It doesn't matter, So I like, I said, for example, this, let's say this is a coefficient, let's say this is intercept, but its a p-value is more than 5%, means it doesn't matter in your model. Slope is, this, let's say scanner, this is, the slope. So let's say this is a slope, but the value is, then this is useful. But if you look into this slope and the p-value is 80%, 81%, means this is not useful. So coefficient, you can't see the coefficient by, looking, the value of coefficient. You can't say whether this is significant or not. It has to be related with the probability, whether,
Perfect. That's exactly what I needed to know, because I was looking at another video and they were almost implying that the coefficient had some bearing on the validity or the regression model. But then I was thinking, well, some of those coefficients, although they may show some validity, the p-value is too high.
Yeah, so don't consider, because I think I will show you, here, you will see the live why that is. Okay, let me or I can show you right now so that you can understand.
Thank you so much.
Look into, I'm just going to have scanners. Scanner is p-value how much? 84%. So I'm going to do two cases, and one I'm going to have p-value 0. It's a, scanner value is 0, and one is going to be high, which is high is how much? 5. And let's see how it is working. So I'm just going to say statistics, regression, and then regression and predict. So scanner, one case I'm going to put 0, and one case I'm going to put highest value here. And there, rest I'm just going to put, exactly same values. 4, 4, 4, 4, 4, 4. Means I'm not changing anything. I'm just picking one variable, which is a scanner, and rest I'm just using. I think we filled all the variables. Okay, so now two only, I made only one change here. One is 0, one is, and look how much difference it creates when you have highest value in the same variable and 0 value. 0 means this variable does not have. So first thing is this, scanners, everything is 4 and the scanners is 0. What is the fit value? This is 4.29. Please, 4.29. And now here I have 5, and look into fit value 4.18. So if you put 0 and if you put highest, the difference would be just, point, how much? I mean, point less than point, less than about, 0.1 only. Can you see? So in a whole model, if this variable scanner is not there, or scanner is 0, or in this model it's useless, if you have highest value or lowest value, it will not impact much.
Okay, awesome. Thank you. And then lastly, I just, when you say for us to make, I'm sorry, I don't have the exact wording, but to make a comparison on, or to make a prediction on our home value, or is there a specific, do you want us to just write something out in regards to what we think?
Like I did exactly the same thing. You are, once you have this data of your home price, or, your neighborhood, you go under this statistics, regression, predict. So you are going to put, your bedroom of your house, 3 bedroom, 2 bathroom, 3 garage, and whatever other variables, lot size, constructed site. So you are going to put exactly these numbers of your house, and then you can see the based on a model what is going to be the home price.
Perfect. That's what I needed to know. Okay.
Did you explain what these, like this, the example that you're working on right now, the scanners, lift tops, like what is that referring to? I don't think I remember, like, I don't know what this is talking about. Like, I understand like for the homework, bedrooms and all that kind of stuff, but what is snow surf crowds? Like, what is that stuff?
This is a fill in the blank. If you look into the fill in the blank option,
Oh,
this is,
okay. So it's from the work this week. Okay.
yeah. So this is a, it's a this is a resort data where, these are the different variables. I think even if let me go so you can
No, that
understand.
makes sense. I wanted to watch this live before I went to the work this week. So now I understand. I just haven't got that far.
Okay. So I think I have to go back on regression. So now you can see these are the t values, these are the p values, and you can see I'm coming. So look into all the p values of each slope and each intercept, or one intercept, which is only one, and look which are useful and which are useless. So you can see which are useful and useless, checking p value. I will explain about VIF, coefficient, standard error, and t value. So you can, so what is the, and coefficient, standard error, t, what is the relationship between this? So t value and standard error of coefficient equal to coefficient. So 4.31, if you, I just take the calculator, and I think, so it simple calculator, so you can understand. And I think for that, I have to share my entire screen. Okay. I hope you can see my calculator. So 4.31 multiplied with 0.627. And you can see this is coefficient. Similarly, all the coefficient you can see here, let's say snow surf. And snow surf, where is that? 0.4 into 0.0568. And you can see 0.0. So basically this is, so coefficient equal to standard error into t value, that makes coefficient. So if either two are given, you can calculate the third value. Now, what is the VIF? It's called variance inflation factor, which is one of the most important item in the multiple regression that explains the multicollinearity. So I'm coming on, that. Now look into model summary. So this is a model. This is standard error of model. So, this is 0.80, which is, if it is close to 0 means your model is almost ideal. So R square is 9.92%. R square means this is regression coefficient, or regression is R square, it is known as, means 9.92% change in over value, or this depends on these variables. So 9.92%. What is R square adjusted? R square adjusted is always less than R square. Why? The reason is that because some of the unnecessary things are removed from the model, and it is I request you to kindly mute your microphone. So is there any easy way to display VIF in Excel regression or core? To be honest, I have to check, but certainly VIF would be there, because without VIF, we can't go ahead with regression. So R square is, including all the everything. Adjusted R square is removing the useless items from the regression. So therefore, this is always less than R square. R square, this, it is, more refined, more precise, but we don't use this. Only use C R square and adjusted R square. Why adjusted R square? Because you can see these items fits unusual variables. So when they make the model, it is, so these are, useless observation or unusual observation. It removes this, it removes the useless variables. Therefore, R square adjusted is little bit smaller than this. Now look into this regression, whether our overall regression is valid. What would you say? Is this regression overall R square is valid? So here you can see this is the p-value for checking the overall R. This is the, and p-value is less than 0. Oh, p-value is less than alpha value. Therefore, we are going to say, yeah, this is useful, this regression. And again, these are the variables. So the regression, overall regression is, yes, valid. Even in 9.92%, which is 10%, this regression model is valid, and its p-value is this. However, few items are, invalid or useless in the model. Now we come to these are the, you can say, observation number 1, observation number 39, observation number 182, observation number 350. All these observations are unusual, means you can see some error in the data, or maybe some out of the way, or which are not fitting in the trend. So these variables you just go and check with your data entry or wherever data got, double check it, or you can remove these items in order to do, or in order to get better model. So these, in this, how many observations are there? I think 30-40 observations are, I think 50 observation, almost 50 observation, 50 data points are not appropriate. So you can remove, or you can correct, or you can double check. It gives you the indication. So this is, now after this, there is a Darwin-Watson test, which is related to time series import, So when do we check? When you have any time series item in this, if this is less than 2, more than 2, or equal to 2, all 3 conditions we are going to see. So this is regression model, complete regression model. How do you check? There are other things which you need to understand, which is called multicollinearity. What is multicollinearity? If 2 variables are exactly same, means they have very high correlation. So here you just first, when we check the correlation, you see here which are the highly correlated items. I don't see here, any items which are highly correlated, like 90%, 99%, 100, or 0.99, or 100, or 0.82. So look into that. I don't see any item which is 100% or close to. So in this model, I don't see anything which is highly correlated. I think highest I can see 0.577, which is crowds and lift weight. which is 0.577. I think this is the highest in this model.
What about 0.6525, the lift up in the scanner?
Yeah, so yeah, that, you then, you just note that and you look into the VIF. So where is, so here I don't see, but I can go into VIF. Where is VIF? I think this is right here. Now look into the VIF. Variance inflation factor. It explains the multicollinearity, because if two variables are behaving, highly correlated and they are having exactly the same impact on the regression model, then we have to exclude one. And here I see it can be explained by variance inflation factor. So let me show you some slide then. Oh, I think slides are right here. Okay. So this is the very first step. Just yeah, multicollinearity. So here, you can see the VIF factor, and this is multicollinearity occurs when independent variable, like two independent variables, are intercorrelated instead of being independent. If they are highly intercorrelated, then it creates the problem. Occurs only two predictors are correlated. And this is a real concern because you have the two same kind of variable, which creates a problem. Therefore, you can see this is the, if this VIF factor, you can see only VIF factor. If VIF factor is 1, no variance inflation, no multicollinearity. If it is 2, mild variance inflation. If it is 10, strong variance inflation. And if it is 100, severe. Therefore, if you have 1 to 2, no problem. If your variance inflation factor is coming 1 to 2, that's no problem. If it is coming up to 5, many researcher, many people, those who have, they consider up to 5. But beyond 5 or 5, 5.5 or 6, up to 6, it depends upon different situation. But, more than that, you don't consider, model. Then you just exclude where you are getting high VIF, exclude those variables to make model validate. Otherwise, if you have same kind of variable in the model, then it will be a concern. You will predict something unusual, which is not real. So you just need to think about VIF in that case. And so you can see the rule of thumb. There's no limit of magnitude of VIF. VIF can be anything. A VIF of 10 says that the other predictor explain 90% of variance of predictor J. So basically 10 means 90% variation of other, two predictor. Therefore, just keep this. These are the points to need to consider when you do the model. Now, there are other issues related to that. This is another p-value is less than means not normal. So are error distributed normal? So how do we see that errors are distributed normal? I go again on my Minitab. I think I have to do. Okay, so this is my Minitab. So this is, my error part, which we saved when we run the regression model. And I go here under graph. We have probability plot. Okay, and I can go and I can select the residual. And you can see the again same. And you can see clearly our error distributed normally. I mean, by plot, we can see these errors are not distributed error, because null hypothesis in this case is null hypothesis error, or, distributed normally. That means p-value must be greater than 5%. H1 error not distributed normally. So clearly it's less than 5%. And we can say here, so yeah, test for normal multicollinearity are already explained. Multicollinearity. So there are three things. Are error normally distributed? Error have constant variations? Are errors independent? So these are the three assumptions we have to check after this. Errors are normally distributed, null hypothesis, which errors are not normally distributed. So you can clearly see if p-value is more than alpha value, you can say they are normally distributed. If p-value is not, in this case, we don't have so we can clearly see the normally not distributed. Then other thing is non-constant variation, heterozygotic, errors have constant variation, errors have non-constant variation. So this is another thing that how we can check. So you can see this is non-constant variation. Heterozygotic, if you see funnel in, funnel out kind of situation, then you can say heterozygotic. If not, then you can see. So how I can see? Look into this. So I'm just going to create, I'm going to use in this time, or you can directly say assistant based regression, multiple regression. Response variable is this, and I'm going to select rest of them here. And category I don't have. I'm just leaving rest automatically. It takes rest automatic. Oh, too many.
You included the value.
Oh. Okay. Minimum number of column 1, maximum. Okay, it can only go up to 5. So let me do the 5 only so that you can understand. And here you can see where, so this is, here you can see large, unusual, and I can't understand what kind of this shape is there. Unequal variances like this. This is something. So I'm not able to recognize this pattern. So basically I don't see this is funnel in, funnel out kind of situation, but I can go again in my regression model. So I can go regression, fit regression model. And here I have the options, some of the options that I am going to check to see if I can coding step. I have some graphs somewhere. Okay, I can see here the graphs, or I can see all of them, or I can see in fit 4 in 1. Let's see. And I can see right here. And I think this is so this is a normality plot that we checked by individually. You can see, I can't get here the p-value, but you can see are errors normally distributed or not. Here, this is fit versus, so this is, can we say this is not hetero, the variance is not here. I can't see this because this is something. So basically, if this is funnel in, can we see no? So this is unequal variance situation. Basically, we have to check this. So this is the third thing in this model, which we have to do. So funnel in, funnel out, auto-correlated. So H0, errors are non-auto-correlated, errors are auto-correlated, and it can be done using Darwin-Watson statistics. So this is usually done when you have some, like in your time series data, you have like year of construction in your discussion, year of construction of the house. That is a time series variable. In that case, you can check the Darwin-Watson also. So Darwin-Watson, here clearly, if DW is less than 2, it's a positively auto-correlated, and sorry, less than 2 is positively, and more than 2, it negatively auto-correlated. When H0 is true, that no autocorrelation, the Darwin-Watson statistics will be near 2. So this is unusual observation. I already explained. I think what is left. Another important thing is about how many predictors should be there in the model to predict, to run the regression. So I think there is a Evans rule. There is a 2 rules are there. Just a minute. Yeah, these are the 2 rules. Evans rule and Duane rules. Duane n upon k is greater than or equal to 5, at least 5 observation per predictor. Then this is good to go. So this is relaxed, this is our book author rule. But if at least you should have 10 observation per predictor. At least 10 observations. So if you have 5 variable, 5 independent variable, 1, so you should have at least 10 observation per predictor to do this model. So when the data is sufficient, then only you do it. If only 2 observations and you have 10 variables, then regression is not, because R square will no longer gives you reliable information. So I think I explained almost all concept of the chapter. Yeah, let me go on other slides that I have. So let me go from one by one because I explained all, but if something I missed, I can cover that also.
Professor, can you clear the screen?
Yeah, I'm just going to do that. Just a minute.
Thank you.
Yeah, this is clear. Yeah, many things I have to do simultaneously. So significance level, assumptions, Evans rule, I think I already covered. These are the different regression, fit regression model. What is the meaning of R square? Means interpretation of R square. So let me go into this and let me explain. So basically, if you see, this is effect over value, or this Overall value is the effect. And these are the causes. So 90 or 9 or 10% of overall value is due to these independent variables. So basically this is cause, correlation is simple relationship. If somebody asks in many interviews, these 2-3 questions are very common in interview. I know all you are very senior level people and you are already stable in your job. But when I teach to undergraduate or graduate people, those who are and they face the interview, 2 questions are commonly asked in interview. Number 1, what is the difference between correlation and regression? And second thing, what is multicollinearity? I think I wrote correct. These are the 2 things which are, so correlation is a simple relationship between 2 variables. Regression is causal relationship between 2 variables. Means these are the cause and this is the effect. So this is a causal relationship between two or more variables. And correlation is very simple. So this is what is multicollinearity? I already explained, because if you are selecting a similar, like, these 2 variables, let's say, okay, I draw. Okay. Let's say you select these 2 variables, they have exactly same nature. Then, the model will be misled. So therefore, multicollinearity has to be checked always. So multicollinearity already explained. This is already, so I think I explained almost all concept. So R square means 9.92% of change in overall value can be explained by all these variables, which is, all these variables, scanners, lift offs, all. So this is in simple way. In simple, there's another relationship which you can say R is correlation coefficient. So R square equal to, so if you multiply R 2 times correlation coefficient, you get the regression coefficient in simple regression. Simple regression means 1 dependent and 1 independent. However, this is not the case here in this multiple correlation, because many correlation are there and this is differently calculated. But in simple correlation, if you multiply correlation 2 times, means R into R, you get R square. So this is another thing. I think I covered all the concept of this chapter.
I just have a quick question. So in regards to the R square, the simple way for me to remember it is just the measure. It's just a measure of how much the variables, the independent variables, affect the. No, am I saying that right?
Yeah.
Right? Did I say that right?
Yeah, because everyone is having a different way of framing their definition. I simply know that 9.92% of change in overall value is due to these variables. So you also said almost same, but you can also read books that different books have different way of explanation, but this is.
Yeah. So in regards, like, for example, what I was thinking about was our home value. So basically the R square is giving us an idea as to how much the collected variables are affecting, for example, the home value.
Exactly.
Okay.
Exactly. So how much is the contribution? What is your R square in your home value?
Mine came out to 0.45.
45%. That's correct. That's good.
Yeah. But in reality, that's just an eyeball way to have an idea, right? It doesn't really give us any real information in regards to the individual variables, correct?
It doesn't give the individual, but
Yeah,
it
it's not, yeah, it doesn't give any individual variables any more significance, right? It's just a way to see if those variables are actually having an effect on the home value. Is that
yeah,
correct?
you can go and check one by one, one
Okay.
dependent and one independent. You can go that. There are other methods that gives you stepwise regression model, which is the most important predictor in your model. Let's say, home value number one is year of construction, maybe, one of the important variable in many houses, number of bedroom, bathroom, a square lot. So basically you can get, which is the number one, which is number two, which is number 3, 4, 5, and which is the least one. And here you can also say important and usual, unusual. So first you remove these things which are useless, keep the useful, and you can get the, more sense. There are many methods in regression, like you can see here. I'm not going to explain all of them, and we don't want to logistics, binary, and different other things, orthogonal, but we are just using the simple, which is based on partial least square method, PLS.
Okay, and then I have one more question as well. Sometimes I get a little confused in regards to the significance F versus p-value.
Yeah.
So I know it should be significant F should be also less than 0.05. Is that correct? If that's our alpha?
F is a statistics. F is the statistics value. And, I think we have to go back in previous course to get all these things, but, just you can also do the F value, in book, complete formula, everything is given there. ANOVA is, you can do that, but here p-value, since, we learned all these things in last course, I think most of the students are from last course, and this course, I understand all of you have the prerequisite requirement before coming into this course. So we did all these statistics in the last course, and we are just focusing on p-value. So p-value is better. Now if you see the F value and p value, you have to see the critical values. What should be the critical values? And then you have to understand all individual distributions. So p value is the, I think those who are coming from 503, they understand p value is very easy to go ahead.
Yes. Okay. Thank you. I just wanted to clarify that.
If you don't have any other question, I would like to say have a wonderful night, and we'll see next week on next Tuesday.
Thank you so much.
Have a wonderful week ahead to every one of you.
Thank you.
Thank you.
Thank you.
You're welcome.
Thanks.
You're welcome.
Thank you.
So, Professor, I have a question for you.
Yeah, please.
So, on the Zillow for my zip code, the
Okay.
sold value is not available.
What value is?
What the price actually was. Only the for sale price is available.
Okay, so I mean, my simple thing is that you can choose any other area that you like. Let's say you select Seattle, or you select Spokane. It doesn't matter, not your area, and then you select any random house that if that has 3 bedroom, this lot area, this, and predict that.
Okay.
So it's certainly in certain areas it is not clear, like remote area or village area. So I can understand.
Okay. No, I just wanted to make sure that was okay.
Yeah, that's okay. Yeah, basically, these discussion are given so that you can feel what is really how we can apply in real situations.
No, that makes sense.
Yeah,
Appreciate it. Thank you.
you're welcome.